Hi everyone, quick intro. My name is Muthu Govindarajan. I lead the AWS and GCP Big Data Engineering practice within Tiger. Most of my career I've spent on data engineering, right from the data warehousing world to the recent big data cloud ecosystems. Happy to be part of this session, DES session today. Today we plan to cover some of the recent and interesting trends we see within with our customers, right? When we are working with numerous customers in Tiger. Many of these trends that we are talking about are creating high impact, right? And on top of data platforms, data lake solutions. I think I'm sure this will be very interesting to you, right, as we go through them. Over to you, Manish.
Hey, hi everyone. This is Manish Gupta. I'm partner data engineering within Tiger. I heads the Azure Big Data Engineering practice within Tiger. I come with close to 19 years of experience of working on data warehousing, data lake, cognitive AI solutions, being on cloud. So entire career has been on data analytics side, and very happy to be presenting today with Muthu on some of the key trends on the data lake side and some of the new things what we see within our customer base. So today what we are going to be doing is we'll be talking about the next gen data lakes and some of the emerging trends what we see in building modern data platforms within our customer base on what all new things are emerging, what all new patterns are emerging when it comes to building data lakes on the cloud. In the last 20 years there has been tremendous changes and evolution which has happened in the overall data analytics platforms and the solutions which customers are using. Things started with implementing things by having just data storage systems to manage the applications. Then came a time when it was required to do some basic reporting, MIS reporting kind of things. Then the data warehouses started showing up when there was more increased adoption of reporting databases. More and more users were looking forward to analyze the entire system, entire data sources in a combined way. And then when scalability was challenged, then MPP databases or data warehouses were some of the initial technologies which helped in scaling up the data warehouses on-prem using various appliances and all. But in the overall data lake journey, when this whole data lake got started, the big data platforms, Hadoop, Spark are the key technologies which gave the right wing to this entire data lakes. Started with these different companies like Hortonworks and Clouderas and Mappers of the world, which were running on-prem and helping customers to analyze their large volumes of data, store large volumes of data within the data lakes. And now we are in a phase where we are adopting big data technologies, cloud, data warehousing on cloud, and coming up with these new kind of solutions like streaming and IoT solutions. And the data lake itself is evolving a lot with the new paradigm of new patterns of using data fabric and data mesh as well. Now, over this time, the whole business value has also increased significantly in the recent past. Now, when it comes to modern data lakes, the data lakes have evolved, a lot. It's no longer just an IT-centric way of storing and managing the data. It is now serving all kind of users, all kind of businesses within an enterprise. The whole landscape of the use cases or what you can do with the data lake is changing as well, right? New kind of use cases, new kind of advanced analytics is being now done on the data lake, and data lake is becoming that technology which is capable of delivering all those different kind of use cases. I was looking at some of the industry reports as well, and in the last few years, the whole data lake market has increased a lot. In 2020, it was somewhere around 3.7 billion USD, and this is something which will grow to 4 to 5x by 2026. And one of the key reasons for this whole data lake to get evolved or its market size increasing is primarily the kind of benefits what a data lake brings on board, right? Ability to bring in data without having doing a lot of modeling. What somebody would do in data warehouse is one of the key things why data lakes have been evolved and getting used a lot in the current enterprises. Muthu, why don't you talk about some of the new trends what we see on the data lake side.
Sure, Manish. Sure. So as Manish explained, right, data lake has been there for years now, right? This is not a new concept or a new topic that we are going to talk about. But interestingly, it has been evolving over a period of time. So essentially, we are kind of summarizing our the high-level trends we see into various segments here. The segment number one is what has been there, right, over the last few years. I'm sure a lot of our customers and I'm sure a lot of engineers also have been seeing these trends. But some things are getting better. Some capabilities are really getting better. Some new capabilities are coming in, which is also creating a lot of big impact, right? In terms of reducing the TCO or in terms of improving the time to market. Those are the ones that are, there are some that we are going to pick up today and then deep dive into some of them. And some really cool ones are being discussed, may not be really mainstream today, but the cool ones are really bringing interesting capabilities to the data lakes. But those are the ones we see really to come up, right, in future, and that's going to create a lot of impact down the line. So let me quickly go through one by one. Segment number one is what's been there, right? What's been there? Cloud has been there, big data has been there, right, for so many years now. But to what extent we are able to leverage those capabilities, bring in those elasticity capabilities, right, and ensure our data platforms are able to reduce the cost, right, over a period of time and improve the performance. So that is leveraging. To what extent we leverage big data and cloud, right, is the question. Second is data ops. Automation around data platforms has significantly improved over the last few years. I think there is a lot of buzz around data ops in the industry. So DevOps has been there, but how do we go beyond DevOps, right, into data ops and bring in automation, right, across the value chain? That is the concept of data ops. Then again, data platform architecture building itself, right? It is a combination of leveraging a lot more reusable engines, frameworks that can be configured, right, rather than programming more and more. So this configurable, reusable frameworks has been in the industry for so many years, but most of the customers have adopted. If not, I think these three would be. If we would look at all these three as table stakes at this point in time. Moving on to the second segment is where what's getting better, right? Though data lakes has been there, interestingly, the granular level of updates and deletes and inserts that we could make within data lake, right, which has not been there earlier, is coming in. So what does it mean, right? What does it mean for us? With increasing compliance, for example, GDPR, right? GDPR, there are requirements for right to forget, which means you'll have to go and figure out one customer record in your entire data lake, right? Large volume files, and then go back and delete them. So which means you need those granular, efficient updates, deletes, right, inserts into your data lake ecosystem as well. Second is how do we control these data lake systems are evolving, and these are also bringing in granular data controls, which means show only what is important, what is necessary for the respective power users. So that aspect of that capability is also coming in a lot more into data lakes. Third is from a consumer perspective, analytics users are the most important users, right? They are coming in and trying to leverage the data and generate intelligence. So powerful tools that are self-service based, where they can on demand come and provision the data that they want, right, and then leverage them. So these things are, we see at least in the recent times, are getting better and better day by day. Let's go to the next segment. The next segment is about, okay, having seen all of this, what are the things that are really creating impact, right? Really reducing the TCO, really improving the performance of the data lake platforms. I think 4 items we have called out here. One is self-service is getting extremely powerful, right? Data ingestion, data processing. How do we more and more push some of the things back from IT, right, into business, into people who are really consuming it, right, for them to do it on demand. So self-service based operating the data platform on a self-service way is something that is getting better and better day by day. The low code, no code approach, right? For a lot of customers are in the modernization journey, right? They want to get away from the legacy platforms, move away into the modern platforms. So the entire modernization journey is also accompanied by low code, no code approaches. Third one, I think the virtual data lake houses, Manish is going to drill down on some of these topics, right? And the fourth topic is about data platform observability. All these, at least 3 of these 4 topics, we are going to drill down the subsequent set of slides. So I'm not going into a lot of detail. The nice ones, the cool ones that we see is, interestingly, metadata knowledge graphs, right? Many of these metadata management tools are able to bring and link the different types of metadata, ability to search metadata only when you have a backbone, like a knowledge graph in the backbone, right, of these metadata solutions. That is when you can leverage the power of this metadata information that we've gathered. Interestingly, we are also seeing containerized workloads, right? I'm sure you would have seen Spark running on a Kubernetes ecosystem, right? Though, what do these workloads bring to the table? So that is a very, very interesting trend that is also getting mainstream day by day. The last but not the least is the hybrid cloud architecture. Customers are also looking at leveraging best of the breed tools in different cloud platforms. This is very, I wouldn't say it is mainstream at this point, but a lot of discussions around how do we make some of these unique use cases, right, working in cloud ecosystem. So that's at a high level. We are going to drill down on the third segment here in the next set of slides. Can we go on to the next one? So Manish is going to speak about how do we improve speed and agility. I think we talked about self-service. How do we bring in an intelligent data catalog, right? How do we improve SQL and query performance through virtual lakehouses? These are the three topics that Manish is going to cover. Post which I will jump in and talk about data and platform observability topics. Over to you, Manish. Please go ahead.
Thanks. So as Muthu said, right, I mean, one of the key emerging trends with the data lake is data lakes are no longer going to be an IT-centric platforms, right? It is now more and more getting used by the business themselves, data scientists themselves, business analysts, data analysts themselves, right? Now, one of the key things which can really help in bringing in the right agility in the entire data supply chain is primarily about enabling self-service capabilities on the data, right? So what we mean by self-service is basically enabling all type of users, whether they are from IT, not from IT, right? Whether they are data engineers or any kind of users, to easily manage and govern the data on the lake themselves, right? And in a cloud data lake environment. Now, within any enterprise, in any large enterprise, right, data lake management is one of the key things. And many times we think that, hey, it's, for implementing a data lake, what you need is very, robust, scalable data pipelines. For example, building things in ADF or Databricks or, Airflow, etc. You build those pipelines, you build those flows, which will bring in data, which will transform the data, which will deliver your data to the downstream systems. But that is only half of the story, right? I mean, building only the pipelines is not going to be enabling your data lake to be, which can be fully utilized or fully leveraged by the business, right? What is really required is to bring in the right automation and self-service capabilities onto the data lake, right? So abilities like for any user, let's say I am a data scientist, I want to ingest data into the lake on my own, and I don't want to rely on, I don't have time to wait, for data engineers to create pipelines and all. So how can I bring in data, ingest data onto the lake on my own, right? So having those kind of ability to go and wrangle and transform the data in a visual way, monitor and tune the pipelines, monitor the health of the data, perform data lifecycle management operations on your data lake as well, right? For example, you may want to clean up some data sets. You may want to, Muthu was talking about, in case of GDPR, you want to go and delete certain records, right? How can you do it in a self-service manner? So those kind of capabilities are required. So implementing these kind of automation and self-service capabilities is something which is really going to be making your data lake more powerful, will bring in the right agility and speed into your entire data analytics supply chain, right? So once you have implemented such kind of automation self-service capabilities, it can bring in agility and operational efficiency. It can, you can implement your data pipelines following various best practices and implementing the governance features at the core. And if you are building self-service capabilities on those pipelines, you will avoid implementing any, fragmented way of data pipeline implementation, right? Doing this automation and self-service capabilities will also help you democratize the data, your platform, the analytics capabilities to all type of users within an enterprise. And this is something which can really reduce the overall burden on the IT teams on doing the same thing again and again of, setting up the pipeline or, doing some basic transformation, etc. And users can themselves basically do these kind of things. Now, the big question is how do you implement such kind of self-service capabilities in an enterprise, right? So in any data lake implementation on cloud, what we see is there are different kind of services which are used on the cloud platform. For example, you may be using storage, compute, networking security, monitoring and governance services of any cloud infrastructure, right? DevOps capabilities of that particular cloud platform. Now, using those cloud native services, what you would do in any data lake implementation, you will start building various reusable frameworks and components say for acquiring the data from one type of source system, right? Building components which can understand the schema, infer the schema, understand the data quality. You implement certain functionalities of, when you are bringing in the data or transforming data, how you load it into the target side. So you build all these small reusable frameworks and components using those cloud native services, platform services, and then using these reusable components, you build those data pipelines for ingesting the data, wrangling and transformation, egress of the data, or doing any housekeeping or maintenance kind of operations, right? Now, many organizations would stop at this point thinking that, hey, this is my data lake, but stopping at this point is not going to be, unlocking your the entire potential of the cloud data lake. What you built, you may have built a very strong, robust pipeline, but it may not be getting used by all the users in a very easy way, right? So one of the ways of implementing self-service is basically you wrap up all your pipelines and various jobs with microservices and APIs, right? You can build various REST endpoints, for doing any kind of pipeline creation, deletion, updation, monitoring the pipeline. You can create REST endpoints for scheduling and triggering the pipelines. You may want to build various services which can go and discover and manage your data set or manage your cluster, right? Or also perform various security and user management kind of activities using those core pipelines what you have built. Now, once those APIs have been created, then you can add any kind of self-service interface on top of it. For example, you can build a web UI based interface which can orchestrate all these operations, and help any kind of user to just go point and click, navigate it, bring in the data, transform the data, send out the data, or manage the pipelines, etc. Right? You can build various automation scripts as well. One of the interesting things what we have done in Tiger is also build a virtual assistant which can actually ask a user, hey, what kind of operation you would like to do within a data lake, and following the similar kind of an architecture of building everything within the services. This bot can actually go and bring in data, transform data, etc. Right? So there are multiple ways of bringing in agility or self-service capabilities within your platform if you follow this kind of a route of building pipelines and then wrapping them within REST endpoints and then using various self-services interfaces on top of it. So this self-service will enable you to bring in data at rapid speed, transform data, egress data, etc. Now, once you start doing that, you will be acquiring and storing huge volumes of data, multiple data sets on your lake, right? One of the challenge which starts showing up is that because you acquired so much of data, how does somebody go and find out what data set is of real use for them, right? So this is one of the things in which a data discovery solution, a data catalog solution can really help a lot, right? So a data catalog solution can understand the different data assets which have been acquired onto the lake. It can understand the health, the reliability, and how those data sets are getting used, and then it can help any consumer, whether it's a data scientist or a data analyst or a business analyst, in assisting them in doing the insight generation, right? So these data catalog has been there for quite some time, but now what we are seeing is like these data catalogs are becoming more and more intelligent. It is no longer just about bringing in the technical metadata of what my tables and databases and schema are, but going beyond and even understanding how those data sets are getting used, how they are getting consumed within your ETL pipelines, etc. So this whole catalog is becoming more and more intelligent and plays a significant role in any data lake implementation to help different users, right? So some of the questions which a data catalog, which have been built in this kind of an intelligent way can answer is, somebody can go and ask, hey, what all data sets do I have? Right? It's a very simple question. How big are they? When were they last loaded? How did this particular data lake ended up in my lake, right? A lineage can help you understand that, right? So lineage is one of the key aspects of any data catalog. It can also bring in or consume data from data observability solutions or data quality solutions to figure out, is there any PII information in my data sets, right? It can help you answer things like, hey, I can see, I want to combine my, let's say, sales data with a particular manufacturing part, right? How can I join, or what is the part by which I can combine these two different data sets? So a data catalog, an intelligent data catalog solution can help you find out, what are the possible ways of linking one data set to another. It can also help you do some impact analysis. Let's say you are working in a very large data lake environment and you want to modify a particular data set, right? So a data catalog solution can help you understand or identify what all things will get impacted if you are changing the one particular data set within your lake. It will have the entire lineage, can tell you which will get impacted downstream because of the change what you're trying to make. Right? It can also help you recommend some data sets. All the users who are using a particular data set for HR analytics are primarily using, let's say, a particular kind of data set. So it can answer you those kind of questions as well. You can compare schemas across multiple environments, which has always been tough in any data lake, right? So, and similarly, what these intelligent data catalogs can do today as well is are capable of cataloging your unstructured data as well. Say, for example, if you are bringing in a lot of images and video files and audio files into a lake, the catalog solutions can actually extract the information from those assets and help you identify, let's say, is there any harmful content in any of that content? Right? So there are multiple use cases, with this intelligent data catalog, which can be solved if you've done in this way. Now, how do you implement such a kind of intelligent data catalog? So as Muthu was also talking about earlier, in the trends. So one of the key things which can really help in building this kind of intelligent data catalog is using a knowledge graph and some powerful search technologies. So you have different data sources, you have different places where your data assets would be residing. For example, relational databases or your big data systems, BI dashboards, ETL, etc., from where you would like to first crawl, scan, bring in the different data assets, their information. You may also want to bring in profiling and PIA information from your observability solution as well. You may want to bring in information which might be there in your unstructured documents as well, as part of your scans. You can do similarity analysis and a lot of other analysis in terms of understanding how these data sets are linked together and how similar they are. And then you finally load to a graph, right? So loading to a knowledge graph, could be something as simple as, hey, you have a data set which may be belonging to an environment and, coming from a particular source. And this data set would have, information like schema, data quality, profiling statistics, PII classification, etc. And it can, the solution can bring in these kind of things in a very automated way, right? And then it can also figure out, hey, who is the owner of that particular data set, who all users are actually consuming this data set from various logs, etc., right? Which is a person, and which department does that person belong to, right? What this knowledge graph could also have is basically how a particular data set is getting consumed within an ETL job, or how it is getting used as part of a particular query. Those queries could be either part of some ad hoc analysis being done by a user, or it could be something like metrics, which is getting used by some charts and dashboards, in your reports. So this is a very simple knowledge graph, which can be, built. And once this kind of a knowledge graph is built, then you can use, different things like search and filter operations, graph queries, recommendations, visual exploration as well, to answer some of the questions what I was talking about earlier. Right? But the key thing is you bring in data, you process that, the metadata from it, and then you load this into this kind of a knowledge graph and be able to answer those questions in a data catalog. Now, we have used self-service for bringing in the data with high agility, transforming it. We can build a data catalog which can help you assist in finding the data sets. Right? But the next thing is, hey, now you have data sets lying in your lake, right? How do you optimize the query performance, of your lake for any user who may not be very good in Spark, for example? How can you implement? Is there a technology which can help you really improve the BI performance as well, right? So one of the technologies which can really do this very well is Dremio, which is kind of a SQL lakehouse platform. It allows users to basically run their BI workloads, SQL workloads in a much more faster way. And the key thing is the users doesn't have to go and rewrite their queries or restructure the data or write any complicated ETL for doing it, right? So it's a data lake engine. It's a data lake querying engine which can really simplify your data access. It's primarily based on Apache Arrow. The reason why it provides very good performance is primarily because of three things from its architecture perspective. It has an auto scale, auto resource scaling enabled because it is running on Kubernetes. It has columnar data caching capabilities, and then there is something very interesting capability within Dremio, something called as reflections. So reflections is like a materialized views, what you would see in any of your data warehouses, right? So you aggregate the data and then use those aggregates or pre-aggregates in speeding up your queries. So Dremio can actually sit between your different data storages, whether on cloud or on-prem, and then the users will connect, or the BI tools will connect with the Dremio in accessing the data, right? And in between, Dremio can cache the data, it can create these reflections, it can auto-scale to provide you better performance as well, right? So the key thing is with Dremio, there is a query optimizer underneath which can understand those reflections, and it can speed up your query without you have to have any specific knowledge about how and what all reflections are there in the system. So I'll give you an example. Let's say you are working with a transaction table, let's say an orders table, right? Now you have aggregated data and you have created a reflection, which is like your total orders or the value of the orders at a day level, or let's say a month level, right? And you are trying to generate a report which is actually running at a quarter level or a year level. Now, instead of you going and specifying that, hey, I want to use a particular aggregate which is defined at the month level, you still continue to run your queries on the base table. And Dremio's query optimizer has that intelligence that it can go and use that particular reflection, which is like already being pre-created for you, right? So there is no need to reference the reflections directly, and there is no ETL involved as well in managing those reflections or aggregate views, right? So this is just one of the technologies we wanted to highlight because it has worked very well in terms of speeding up your queries when it comes to accessing data on your lake, right? So Dremio can actually multiple ways of accessing data. It can go and directly connect with the raw data. It can use the reflections completely, or it can also combine data. If the data is not there in reflections, it can combine data from both your raw data store as well as the reflections for doing it, right? So these three technologies can really speed up your ingestion, transformation, your data discovery, and then also the consumption side of it. So I'll hand it over to Muthu to talk about the data discoverability of patterns what we are seeing now.
Hey, thank you, Manish. Those are very, very interesting topics, right? Okay, let me get down into a very interesting observability topic. Okay, this is very close to my heart. A very, very important topic, I would say, right, in this entire data lake ecosystem. The reason it is that the goal is all about delivering data, right, that is trusted by the business, trusted by the consumer. So I would say everybody is aware of data quality, right? This is a step beyond data quality, in my opinion. We all measure data quality in terms of certain set of dimensions. How confirmed is the data? Is it consistent? Is it complete, right? These are the dimensions in which we measure the data. Timeliness, for example, right? How timely is the data that we deliver to business? How accurate it is? While measurement of data quality through a set of rules, processes is nice, right? But end of the day, there is a lot of platform component into it. How are our jobs running? Are our servers able to deliver the data, right? Or is able to perform to deliver the data on time? So basically, we look at this observability as three different stages, I would say. The first stage, where most of our customers would have already done it, is about basic data health monitoring, right? You have a bunch of rules, you know what you're monitoring, and you have nice dashboards, right? You on an ongoing basis, you continue to monitor the data health, right? That is stage number one. Stage number 2 is, can we go one level above? Can we predict what kind of issues are coming into your system? Can we look at and say, can we identify some issues that are coming up down the line, unknown issues, right? Can we predict them ahead of time? That's the stage number 2, right? If we are able to reach that. The third stage is about how do we even go back and make our platform end-to-end visible, for us to understand the bottlenecks in the platform, for us to understand if our environments are scaling, for us to understand if we are even, if the ecosystem itself is able to deliver the data on time, right? Accurate data for the business. So this entire, so we define, right, from a Tiger standpoint, we define this as 3 stages: stage 1, stage 2, stage 3, for us to bring the trust on the data for the business consumers. Let's go to the next slide, please, Manish. So I'll take, let me take step number 1, right? I'm sure most of the ecosystems we work on, right, this particular setup is already there, but just to refresh our thought process here. On the bottom, what you see is step number 1 is identifying what are the critical elements, critical data elements, right? We don't monitor anything and everything in the data ecosystem. That is too huge. So we monitor only the critical elements. We configure rule-based health checks on that, right? We capture the results from there. We push them into dashboards. And then these are monitored on an ongoing basis. If there are problems in the data that are figured out, then we go back and there is a data quality working group, right, that triages that information, goes back to the source systems, tries to fix it there, right? And this entire process continues. That is what this is the typical data quality process, right? Stage number 1, DQ process that we do. But to even enable this process end to end, right, there has to be a basic data catalog that is available. Data definitions are available. There is a tool through which we can discover information, right? And for the analyst, for the data steward to go back and figure out, right, if this problem is really a problem or not. And typically going back and configuring rules, right? Data quality rules are getting figured out, right, on an ongoing basis. How do we go back and configure that? Dashboards are available. There is a case management tool in which these cases are logged. And we also crowdsource feedback about data quality, right, from different consumers. And how do we action all of this? This is a very, very basic step number 1 in terms of observability. Okay, that is, let's go to the step number 2. Step number 2 is how do we enhance this basic observability ecosystem? Manish, can we move to the next slide, please? How do we enhance, how do we leverage some of the new age tools, right? How do we leverage, for example, AML in terms of predicting some of the problems? For example, you see the one on the left hand side, right? How do we, can we even monitor the drifting of data, the schema drift, the data drift that is happening? Any platform will have incoming data, right? How do we auto classify the new information that is coming in? Can we tag data assets? Can we go and detect some of the PIA information coming in these new data sets? And can we go and recommend the data quality rules, right, for these new incoming information that is coming? So next, even we can go one level above that, right, and then start defining security entitlements. We know there is already a set of data, there is new data set coming in. Based on the similarity, can we go back and automatically define security entitlements? And then even this data catalog itself per se, right, can be built through an assisted process, wherein understanding if that element is already there, then bringing the definitions from there and automatically mapping it to the incoming data. So like that, AML can play significant automation role, right? What you see on the right hand side is a set of indicators, for example, just for you to understand this a little better. Is the data that I'm looking at stale? Is the volume increasing suspiciously, right? Am I seeing too many outliers? How is the population stability index looking like, right? Things like that. How are my important categorical variables looking like, right? What is the relationship looking like? Things like that. There are n number of KPIs we can define, and then leverage AML to an extent for us to automate a lot of this process, right? For us to predict data quality over a period of time. Let's go to the next slide, Manish. So next stage is about how do we expand data quality to platform level observability, right? Ecosystem. What you see from left to right are the typical value generators we will have to look at. These are the capabilities that needs to be built. Okay, for example, monitoring data is one aspect, monitoring data flows, monitoring environment is one aspect. Second is, I think Manish talked about lineage, right? Lineage as an information. We will also have to look at lineage from a performance standpoint. Can I drill down on that lineage to analyze performance of certain data pipelines? Because data volume keeps changing. So how are my data pipelines scaling to different incoming data volume? Third is, can I monitor security, right, on an ongoing basis? So step number, where we are pushing the boundary is beyond the monitoring. Can we analyze some of the key workloads? Analyze workloads to detect bottlenecks, to detect problems in the workloads. So efficient tools that can go back and analyze these workloads and give us intelligence for us to deliver data on a timely manner. Next is about predicting issues. I think we talked about monitoring. Now we are talking about predicting problems, right, that are coming in, predicting delays, pipelines that are delayed, monitoring log files on an ongoing basis. In the end, the nirvana state is all about delivering reliable data, right, on time. That is a state we all want to reach. So to even go there, right, and then we need to continuously keep optimizing these value generators. End of the day, it is like a central solution observability platform, what we call as a unified observability platform, in which all of this comes in, and there are different UI based tools for analyzing workloads, for monitoring data health, for predicting information, right? All of this has to combine, has to act together, right, in a combined ecosystem for us to do this end-to-end observability, right? Some kind of a goal that is where we need to reach. So interestingly, a lot of commercial tools have come in the industry today that can cater to a certain extent on some of these problems that I talked about. But a lot of customers we see also building these platforms ground up, building, for example, Elasticsearch, right, in which you can push all these logs in, all these different information, usage information, all these log file information, right, can be pushed in, and then that can be consumed through a set of UI tools, right, with also some analytical models built in. So observability has been a very interesting trend, and we see this space evolving a lot more, right, in future. Let me go to the next slide, please. I think overall, I think what we have discussed today, just to summarize, we have discussed about self-service in detail. How are self-service tools coming up? How much of work from IT can be pushed back into business consumers, right, who are using the platform? Second, I think Manish covered in detail about intelligent data catalogs, right? Using some kind of a graphical ecosystem in the backend. How do we leverage that, right, to make this entire discovery a lot more simpler and easier? Third is a very interesting topic on the data SQL Lakehouse platform, right? With minimal ETL transformations, can we do some kind of a virtual SQL Lakehouse ecosystem, right? That is one. And the fourth and a very important governance area is about the data and platform observability. Bringing all your data monitoring, platform monitoring, all of this into one ecosystem that is intelligent enough, right? With us embedded with AML models is what I think is the end state we are all looking at. We strongly believe continuous improvement is the way to go. So each of these components are some examples of improvement. There are many other improvements that's happening on data lake today. Nice talking to you. Thank you, everyone.
Thank you, everyone.
Thank you, everyone.